Hi, I'm Charlie with US Water Systems, and today we're talking about the US Water Open Air Aeration System. This particular system is used when you have gases or some type of contaminant that we need to oxidize. It utilizes some inner spray nozzles that allows atmospheric air to be introduced to the water to help precipitate those gases. The gases that are collected are actually collected in the top, and then they're exhausted out the top, out through a vent. Now, when you get the system from us, it's gonna come pretty complete. I mean, you're gonna plumb in and out of the system, and it's already gonna have a ballast tank as well as the inner pump. Some people who have systems like this don't offer the inner pump, but this system is going to be complete front to back. We also offer a water filter, a spin down water filter to knock out any sediment or other debris that may be in the feed water prior to the system. This is important to install because if not, you can actually clog the nozzles that are making the spray pattern. So we always want to install this on the inlet prior to the open air system. The other thing that the system will come with is just a regular PVC ball valve. This is designed to be plumbed on the bottom of the tank like so that way you have a way of removing sludge as sludge builds up in the tank, which it will. When you oxidize, if there's any iron or other contaminants in there, it'll actually start to settle in the bottom of this tank. So periodically you're going to want to clear that out. I'm going to set these to the side, and then this last thing that we offer in all of our systems is an actual leak detector with a motorized shutoff valve. So we also will put this in the system prior to even the spin down filter. It has a couple different sensors that you can lay out on the floor depending on how your floor drains, and what this will do is if you have a leak and water goes across the contacts, it will shut this valve and stop the water, so that way you don't flood your whole house. This is a really good feature to have on any system, but for this aeration system, it comes standard. There's also some buttons on here that allow you to either open or close the valve manually if you want to. But I definitely suggest that you install this system when you put the system in your home. Now, the other thing, and I just have it sitting up on here, is the actual blower. What this does is this is a blower fan, so when the system kicks on and it's bringing in new water, it's spraying out from the nozzles, and it's basically releasing the gas that's in the water, whether that be methane or hydrogen sulfide, whatever that may be, and that's in the gas, or I mean that's in the water. Once it's released, you know, this would be glued and once it's installed, but once it's released, this fan kicks on and it blows that gas out. This is made to vent outside of the house. This is not made to vent in the basement or anywhere in the attic. This must go out of the house and above the roof line to be safe. If it wasn't above the roof line, it could collect some gas even in the yard or underneath the eave and still cause a hazardous situation, because methane is obviously flammable, and if you had a concentrated solution of hydrogen sulfide, that can be flammable as well. So you want to make sure that this is installed properly and follow the manual's directions as far as how to put it above the roof line and what's the proper spacing. The other thing that the system will come with is the ballast tank. This ballast tank kind of helps with distribution of the water after we repressurize it here in the actual system. So again, this system's used to remove gases, whether that be radon or methane. It could be hydrogen sulfide as well. It uses basic principles. I mean, even though it looks fairly large and elaborate, we're using very basic principles here. We're creating a spray pattern that introduces air and also allows other gas molecules to come out in the atmosphere, which in this case would be the top of this tank. So what we're going to do now is we're going to change camera angles, and we're going to come in and we're going to look in the top of the tank here. We're going to explain some more of the components that actually are part of this system. Okay, so when you get your Duke aerator and you open it up the lid and take the lid off, it's actually a twist turn lid. It'll pull off of there. There'll be a couple different manifolds inside here, and there's a submersible pump. Now you can see that the submersible pump is actually tied with a rope. That's just so you don't put all the stress on this union here and snap the pipe off. So when you get it, the first thing, you know, once we have it in place and whatnot, we're going to install this pump on the union here. Now, to do that, you're going to kind of have to hold it plus take the rope off here. I'm going to do it. Hopefully I don't have any issues. You may want to get a helper for this. It's not a bad idea, but I'll try to do it myself just so we can stay in the shot here. But you definitely don't want to just drop it and let it hang. So once you have that off of there, feed it with some tube. Now, if you look, there's an O-ring here. You want to make sure that's in place, because if not, you'll get a leak inside the tank here. So make sure your O-ring's in place, and then we're going to put it underneath the union here and tighten the union down. And then it's good to get a couple pair of channel locks and tighten it down. I'm going to snug it for now for the video, but once it's tight, there's a screw here. I don't know if you can get in on that. Can you see that? That screw can actually be tightened down a little bit, and that'll keep this from backing back off if you want to use that. It's kind of like a locking screw. Now, once that's installed, I want to talk about exactly what we have in here. Tilt that a little bit right now because it's not plumbed in, but if you can see, there's nozzles on each one of these little T's that come off here. Now, this would be the incoming water. So when water comes through here, it shoots through all these nozzles and makes a spray pattern that actually will pick up the dissolved oxygen. And by default, when you spray that, any methane gas or whatever will come out of the water and come up to the lid and then out to the vent. So this would be your incoming manifold that allows the water to come in and spray like in a cone, or in this case it looks like this is probably going to be a spiral cone pattern that it makes, but that will allow that oxygen to penetrate the water, but it also allow any gas that's in the water to release. So once the water comes in and goes through these nozzles, it collects in the bottom of the tank, and then as the water raises up so far, these float switches will shut the water off in the tank. This one will shut it off. This one lower here will turn it on. So when the water gets too low, then this will turn the solenoid valve on and let more water up until that's satisfied, and then it'll shut off here once it's full. Once this kicks off, the whole process starts again when this drops. You know, so you fill the water up, you use it in the house, and it depletes, and more water comes in, and it does the process over and over again. So right now, like I said, you can see that these manifolds are loose. That's because we haven't plumbed into them yet. But what's important is once you have this in place and you plumb into it, that all your plumbing's secure, because you don't want these moving around once you're done plumbing. You want all this to be somewhat secured and can't rock back and forth. Now, this is the basis of this system. These nozzles are the heart of the system. These nozzles are what allows the water to spread out and atomize and actually allow the gas to release and allow oxidation to happen as well. So if this tank fills up, whenever you call for water, it will open up the solenoid valve, the pump will kick on and supply the home. So once you've installed this pump and we've have everything plumbed in, we want to make sure we keep everything perpendicular. We wouldn't want to plumb the system where this is crooked. We want to make sure this is straight when we plumb it in, which basically just means making sure these connection points are straight, which is what we'll talk about next when we change our camera angle. But I want you to be able to see these nozzles, because these are the most important part of this entire system. This is the treatment. Everything else is kind of a means to support this particular type of treatment. But this is the aeration manifold that does the work for you. So now we're going to back up, and basically we'll talk about the connections as well as the controls, and then we'll go over kind of an overall operation of the system and how it's going to work, and what other components that we have. So we're going to change camera angles now, but again, when you plumb this in, make sure this is not crooked, make sure it's perfectly straight in here because we want a nice flow pattern for these cones. So now let's talk about some connection points as well as some of the other components that come with the system. Again, this is the ball valve that you'll get, and you're going to plumb that into the drain down here at the bottom, and that's just to facilitate sludge removal or anything that may build up within the tank. So that's pretty self-explanatory, but these other things I want to talk about a little bit. This particular leak stop valve, if you want to use this and make sure that you're capturing any new incoming water, you would put that on the inlet of the system, which this would be the inlet. This side, you can see that the manifolds are still moving now because we have them loose still in there. But this particular system has its own control solenoid, but this will also act as a safety backup solenoid that you can put in here that will allow you to stop the water if you do have a leak. You can manually open and close the valve too with these switches on this. So this will basically plumb into the inlet right prior to this inlet connection. So you'll have a short piece of pipe from here, and then this will come from your well. Now, with that being said, we also have, like I said, the regular control solenoid valve here. And what this does is, this is just for normal operation. When the tank gets full, this solenoid valve will shut the water off from your well. If this happened to fail and the tank overflowed, then that's when our safety feature would shut the water off from the well. So this would be the inlet, and like I said, you can see it's still loose. But if you plumb both of these level, then you know that your inner manifolds will be perfectly straight too, because that's how they're built, with them built level. So this is our solenoid valve connection. These are our float connections, the low and the high float. This is our pressure switch connection, which shuts everything down once your plumbing system's been satisfied and the pressure's up. There's also a pressure gauge here. So again, you would come from your inlet first and foremost, and then go through this spin down filter first. This will capture any big grit or anything that we wouldn't want to get in those nozzles and clog it up. This will come with a little valve that'll screw on the bottom of here, so you can mount this to your wall, and periodically you can open that valve and blow any grit that it collects in here out. Now this would be the first thing that you'd put in your pipe prior to the system. So you would get this put in, you'd come out of this, you would go into your safety valve, and then you would plumb from your safety valve to the actual control solenoid here for the inlet. And that's pretty much all the inlet plumbing that you would do. That will get you plumbed into the nozzles in there that actually allow the aeration to take place. Now, once that's done and we've plumbed in here, then we're going to plumb out from the other side. Now, this other side is what comes from the submersible pump. So it'll provide pressure to your home. That is also why we use this tank. This tank serves as the ballast tank, kind of like the ballast tank for your well pump. This will give you some volume for showers and things like that when you actually start using the water. So what we would do here is we would plumb out of this, we would come over to here, put a valve in here which is not supplied. You'll need to put your own valve to shut this tank off, and then tee off. So you'll come out of here with a tee, a valve, and then off the tee is what you would run to the rest of your treatment system, or you'd run to your home depending on, you know, what other contaminants you needed to address. But again, out of here, it comes over, tees off, put a valve in here off the tee, and then off the tee you go out to your home or to the rest of your treatment system. Now what happens is once this tank is full, you turn the faucet on, then water will come from the pump through here, fill up this tank, and then out to your faucet. And then when you shut the faucet off, the pump will continue to run until this tank completely fills. Your pressure satisfied, your pressure switch will shut off the pump, and everything sits and waits until you call for water again. So that's kind of the in and out connections. Really, it's pretty simple, in here and out there. Everything else is kind of done for you. And then in the instruction manual, there's step by step on how to plug this in, but basically you're going to plug this into an outlet, and then you start plugging these other components into these jumpers, depending on where it is, in which I'll have that all laid out within the instructions. But actually, I'll come back and I'll just plug it all together here and say, you know, you plug these two in the outlet. But other than that, the only other thing that we need to do is, again, we have a connection for this too, we got to keep in mind. But we have to plumb our vent. And like I said, this vent is crucial because you don't want this gas to build up in your home. You don't want it to build up at the back of your house in the yard. So don't take it for granted and just put a vent right out the side of the house. You want this to be vented all the way up above the roof. And I know that makes it tough, but that is the correct way to do it. That's the safe way to do it. So make sure you run your vent up above the system and somewhere around 18 to 20 inches above the roof line. I'll provide a drawing in the manual that will show exactly what you need to do to keep yourself safe there. But these three connections, as well as plumbing in this ballast tank, are pretty much all the plumbing that you do. And there's really nothing to set here. There's no programming, anything else. This is all just mechanical means that's going to work on a series of float switches as well as solenoid valves. So once everything's plugged in or plumbed in, then it's just a matter of plugging all this stuff in properly, which I'm going to show you how to do that now. Okay, now we want to talk about the actual electrical connections and how you're going to do that. And basically all we need is a duplex outlet. You want to make sure that this is probably dedicated. It wouldn't be a bad idea. If you can't do that, then so be it, but it'd be better to have a dedicated circuit. And I'd like to see at least a 15 amp breaker, preferably a 20 amp, just to make sure that we have adequate amperage for the system. So once we've plumbed everything in, the inlet and the outlet, then we'll have, like I said, you're going to have these two cords that come out of here for your high and low float switch. So you're going to have to identify which one's the high level and which one's the low level, and then you can tag them accordingly on the actual connector. But I've already done that. This is the low and this is the high level. So we'll deal with the low level first. The low level, you're going to want to plug this directly into the wall, and then this particular outlet is switchable by this float. So you plug that into the wall, and then from there we would stick in our next connection, which would be the inlet solenoid. Because what we want is we want this to open up and allow the inlet water to come on and fill this up. So you'd plug that into the inlet solenoid. And then also, when new water's coming in, we want the blower on too, because that's when we need to remove the gas. So this would plug into the low level float as well. So all this would plug into the 110 outlet, and that would feed the solenoid valve, which allows the water to come in, but it also turns the blower on to blow the gas out when we create gas. So the other float would be your high level float, or we call the safety float. That one you will plug directly into the wall, and then this pressure switch would plug directly into that. And basically that's all your connections. You have your inlet solenoid and your blower for your float switch, which will be labeled float switch, and then you have your high safety float that you will wire your actual pressure switch into. Now, when it comes to the leak stop, this should be plugged into an outlet that's constantly energized. That way, no matter what happens here, you still have the protection to shut the water off if necessary. So those are the electrical connections in a nutshell, but really are pretty simple. It's just a matter of plugging things in properly. That will all be laid out in the manual as far as which piggyback goes where and how to plug all that in. Now, you don't want to use if you have an extra outlet, you don't want to use that for anything else. This is all kind of rated for the voltage and the amperage that is exclusive to this system. So make sure you don't plug anything else in there, and make sure wherever you plug this in is a constantly charged outlet. We've had situations where something's in the basement and somebody goes upstairs and flips the switch off and it kills the outlet. So then they call and say, well, the water system's not working, but every time they go down there, it's on because they turn the light on. So make sure it's an outlet that is not switched and is constantly energized. Like I said, there's really no adjustment here because we're using mechanical means to remove these contaminants. Once everything is hooked up and plumbed in, then obviously we're going to check for leaks, and if there's no leaks, then it's just a matter of making sure that the switches are working properly. You're going to cycle some water and make sure that the water shuts off and comes on like it's supposed to. Definitely make sure this blower comes on like it's supposed to, which the blower should only run when new water's coming into the tank. So just because you're using water at the shower or the sink, that doesn't mean that the blower will be running, because you're basically depleting this tank. But once you get to a certain point and new water comes in, then the blower will kick on to remove the gas that we're taking out of the new water. So that's pretty much it. This tank should be pre-charged and ready to go. So once we have everything plumbed in, then you're pretty much ready to go. But again, make sure that, you know, irrigation, anything like that should be plumbed off prior to this system, just so we're not treating irrigation water and because it's going to cost you a lot of money to treat the irrigation water with this thing running all the time with electricity. So sprout the irrigation off first, plumb into the spin down filter through your safety shutoff system, and then into your inlet solenoid valve. Out of there to a T with a valve on here, and then out of the T to the home or the rest of your treatment system. This has been the U.S. Water Open Air Aeration System. If you have any questions, you can give us a call at 1-800-608-8792, and also at our website, www.uswatersystems.com. There'll be some manuals and some other supporting documents for this, as well as the video you're watching now. Thanks.